On our Chapter 5 test review sheet, these two problems, 11 and 12, require solving by using the quadratic formula. So I just wanted to go through these with you. You definitely need to know the formula before the test, so make sure that if you don't have it committed to memory, work on that before you come in to take the test. Well, here it is. Here's the quadratic formula. It's the opposite of b plus minus the square root of b squared minus 4ac all over 2a. All right, so we mentioned in class that this is used to solve quadratics that are in standard form, equal to 0. Well, number 11 is not equal to 0. We need to make this in standard form equal to 0 before we do anything else as far as applying the formula. So quick move, we just subtract 2 from both sides, and now it's set up so that we can use the formula. So here we go. So we're going to do the opposite of b, and maybe I can just refresh your memory a little bit. The number in front of x squared will be labeled a. The number in front of x will be labeled b, and this constant at the end will be called c. So the opposite of b, the opposite of negative 5, will be positive 5. Plus minus the square root of, this says b squared, so negative 5 squared is 25, minus 4 times a times c. Okay, let's just do that in parentheses. 4 times 3 is 12, times negative 2 is negative 24. So this is an area right here where you really need to be careful. I see a lot of people make a mistake here. We are subtracting the product of 4 times a times c. And when you do 4 times a times c, it ends up being a negative number. So really we're going to be adding here because we're subtracting a negative number. And then the denominator will be 2 times 3, which is 6. All right, so let's keep working. And when you do add 25 and 24, you get 49, which would be this, we're going to do the square root of 49 all over 6. Of course, 49 is a perfect square root number. It has a perfect square root, and that is 7. Okay, well, we can simplify further here. A lot of people would get to this point and stop, but when we have two integers in the numerator that can be added or subtracted, we need to go ahead and do that. Okay, for example, one of my answers will be when I do 5 plus 7 and divide that by 6. And we know that 5 plus 7 is 12, and then 12 divided by 6 is 2. So one of my solutions is 2. And now I'm going to do the same thing with the subtraction. Let's do 5 minus 7 over 6. And when you do 5 minus 7, of course, that's negative 2 over 6, which gives you negative 1/3 when you reduce. So again, just keep in mind when you solve a quadratic equation, you're coming up with two solutions because that's the degree. And the two solutions in this case will be 2 and negative 1/3. Okay, let's work on number 12. And the same idea here. It doesn't equal 0. It's not in standard form. So I'm just going to add 6x to both sides, and then I'm going to add 7 to both sides, and this is the result. 2x squared plus 6x plus 7, and now it equals 0. And now I'm ready to begin using the quadratic formula. Okay, so the opposite of b, the opposite of 6 will be negative 6 plus minus the square root of b squared. 6 squared is 36 minus 4 times a, which is 2. 4 times 2 is 8. And then 8 times 7 is 56. And all of that will go over 2 times a, 2 times 2, which is 4. Okay, now let's work on simplifying the radical. Negative 6 plus minus, and underneath the radical that will be negative 20. So we got the square root of negative 20 all over 4. Okay, and then we can simplify the square root of negative 20. So remember, now that we know the number I, we're able to simplify these square roots of negative numbers. So I'm going to write this out as factors so you can see how I got the simplified radical form. So using factors to represent the square root of negative 20, I'm going to use the square root of negative 1 to make it negative. And I'm going to use the perfect square root number 4 times the non-perfect square root number 5. Okay, so all I really did from here to here is I found another way of writing the square root of negative 20. And the reason for that is I can simplify 2 of these radicals. Okay, 2 of these radicals I can write without radical because the square root of negative 1 is I and the square root of 4 is 2. Well, if I put that together, I would write it as 2I. And then I'm going to leave the square root of 5 because I can't simplify that radical. And we're still putting all of this over 4. Okay, we're almost done, but we can just think about reducing this fraction. So you're looking for a single number that will divide evenly into 2, 4, and 6. The largest number that will divide into all 3 of those is 2. So to reduce this answer, we're going to go ahead and divide these 3 numbers. Now, you're not ever dividing into the radical, but the numbers outside of the radical, you see if they are all divisible by the same number, and if so, go ahead and do that division. So negative 6 divided by 2 is negative 3. 2 divided by 2 is 1i square root of 5. And then down here, 4 divided by 2 is 2. So in that one fraction, we actually have 2 solutions because we're doing plus minus. And this is the simplified radical form. So when it says simplified radical form, don't use your calculator. You're not changing radicals into rounded decimals. You're just leaving the answer as a simplified radical. Well, I hope that helps you on problems 11 and 12. You did other problems like this in section 5.8. Many homework problems were using the quadratic formula. So practice those so that you'll be ready for the test. And if you need further help, let me know.